For this example, we will determine the truth value of the following propositions containing logical connectors. To do this, we must first look at the truth value of each individual proposition. Let's start by finding the truth value for the proposition horses are mammals and unicorns exist. First, we have the statement horses are mammals. By the definition of mammals, we can say this statement is true. The second statement says unicorns exist. There is no scientific evidence showing that unicorns exist. So, this statement is false. Since this proposition uses the logical connector and, both statements must be true for the proposition to be true. Since one of the statements is false, this proposition is false. Next, we have the proposition horses are mammals or unicorns exist. As mentioned before, horses are mammals is a true statement, and unicorns exist is a false statement. Since this proposition is using the logical connector or, only one of the statements needs to be true for the proposition to be true, which makes this proposition true. Next, we have the proposition Shelby likes tofu or Shelby does not like tofu. Well, I don't know Shelby, so I don't know if they like or dislike tofu. But I do know that you either like something or you don't like it. I also know that Shelby likes tofu and Shelby doesn't like tofu are negations of each other. This means one must be true, making the other one false. Since we have the logical connector or, we only need one of the statements to be true, which makes this proposition true. Our final proposition says Shelby likes tofu and Shelby does not like tofu. Once again, I do not know if Shelby likes or dislikes tofu. However, this proposition uses the logical connector and, which means both statements must be true for the proposition to be true. Since they cannot both be true, this proposition is false.